Last section in Unit 5, Section 5.8, Radical Equations. So, our goal for the day is to solve radical equations. Mind-blowing. So let's start with this. This is something we've done pretty similar things in the past. We're asked to do the square root of x equals 4, trying to figure out what value of x makes that true. Now, quick reminder, not the most important thing, but just kind of thinking about things in perspective of what we've done in other examples. Square root is like there's a little invisible 2 there. It's kind of like as an exponent of 1. It's just so common we don't write it. To get rid of that square root, we're going to take both sides and square it. And we get, on the left side, the square root and the square cancel out. We're left with just x. And then 4 squared is 16. And that's it. Look at how much space I left. Why didn't I just make this a whole or a problem on a separate page with another one? Whatever. It is what it is. Let's try out something that's a little more complicated. And by a little, I mean just a little. We're asked to solve the equation square root of x minus 6 equals 0. Let's add 6 to both sides. So we have the square root of x equals positive 6. Just like in the previous problem. Let's square both sides. And we end up with x equals 36. Yep, totally could have done those on the same page. Let's get a little more complicated. This next one, we have the square root of x plus 3, rats, equals x minus 3. So we got to get rid of that square root, and let's just get rid of it right now. Let's take the both sides and square them. So the left side's nice and easy. Square root and the square root cancel out. We're left with just x plus 3. On the right side, x minus 3 squared. Keep in mind, x minus 3 squared is not the same as x squared minus 3 squared. We need to do x minus 3 times x minus 3. When we're squaring something, that means multiply by itself. Left side still x plus 3. On the right side, let's actually go through and distribute the x minus 3 times x minus 3. We got x times x, that's x squared. X times negative 3, but also negative 3 times x. That gives us a grand total of negative 6x. And then we have negative 3 times negative 3, which gives us positive 9. Now I'm going to suggest get everything on the same side. So let's subtract x and subtract, not x again, goodness gracious, and subtract 3 from both sides. So we have 0 on the left side equals x squared. Negative 6x minus x is negative 7. I skipped my 7. Negative 7x, and then 9 minus 3 is positive 6. From here, we got to check to, we got to check to see what this factors into. Sorry, my brain froze for a second. We're going to end up being able to factor this into x minus 1 times x minus 6. Now from here, we've got 0 equals x minus 1 times x minus 6. That means either x equals 1 or x equals 6. Now folks, we've kind of glossed over this in some examples in the past, but we should check our work. So let's check out, I'm going to start with the x equals 6. Let's plug that back into our original equation. So we'll do the square root of 6 plus 3 equals 6 minus 3, hopefully. I'm going to put a question mark there because we're not so sure. 6 plus 3 is 9, so we got the square root of 9, and then 6 minus 3 is 3. Is the square root of 9 3? Sure is. Well, let's check out the other one. We got x equals 1. So we'll plug it in. We got the square root of 1 plus 3. So I'm separating these. Equals 1 minus 3. So we got the square root of 4 equals negative 2, which is not the case. So x minus 1, or x equals 1, it's another one of those extraneous solutions. It doesn't make the original statement true. So x equals 1 is an extraneous solution. So our only solution here in this case is x equals 6. So make sure you're checking your work.